Okay, we are going to talk about color theory today, specifically color temperature. Who can tell me what the word theory means? Yeah?
I want to say guess, somewhat like a guess.
Yeah, somewhat like a guess. Okay, color theory. Theories are not factually proven. They're kind of debatable. Color theory is a huge realm of the art world, okay? And we barely touch on it at all in school, and especially in elementary school and stuff. Probably all you guys know about color is like there's 3 primary colors and 3 secondary colors and 6 tertiary colors, and red, orange, yellow are warm and blue, green, purple are cool. But there's so much more, and a lot of color has to do with relevance, has to do with our eyesight, has to do with lighting, has to do with pigment, more than just primary colors. So today we're going to specifically talk about color temperature, which is the visual warmth or coolness of a hue. Hue is another word for color. Every color has temperature. Warm colors lean towards orange. Cool colors lean towards blue. So let's take some color pencils and add some color to our notes so we understand. Okay, warmer colors advance forward. Okay, warmer colors tend to pop out forward towards our eyes. Cool colors tend to recede backward. Cool colors tend to fall backwards into space. Okay, I'm going to use 3 pencils that are all in the red family, meaning that they are all types of reds or have prominently red in them. I am going to use 922. It's okay if you don't have these colors. You can just watch, or you can try and do it with a different family of colors, or you can just watch. I'm using 922, 924, and 995. Go ahead and make a burnished square. It doesn't have to be huge. Don't waste too much pigment. Or a rectangle of each of those 3 colors. So this is kind of my red family. Got pretty much a normal red in the middle. The one that leans more towards orange is my warmer red. The one that leans more towards blue is my cooler red. Yes, red is like a warm color in general because it is like the color of fire and heat. But within that whole idea of red, there are tons of different hues and pigments and temperatures and values and colors. And there are cool reds and warm reds. We can test the temperature of colors in relationship to each other by creating like visual illusion squares. So we're going to do this with the two temperature colors. And if you don't have these colors, it's okay, you can just watch, it's fine. And we want to burnish this so you can, oh, I almost just colored on top of the wrong square, the wrong color. That's stupid. So we can really see like the color for itself. And then if we take that middle red and burnish an entire rectangle around those boxes. Don't leave any white space, like really like color it all the way in.
How do you know if something is a cool red?
It's closer to blue than purple, or than orange, sorry. So when I do these like color swatches, let me see if I can get in without a glare. And it focusing, let's see. One of these squares tends to jump out at me into space. So this color is much warmer than this color. It's kind of easier, I think, to tell with red. And greens are kind of easy to tell. Blues, I think, are trickier to tell, and it more depends on relevance. We can use color temperature to enhance, that's the word, enhance. Enhance our sense of depth, okay, or feeling of space. Because warm colors tend to advance forward, and cool colors tend to recede back into space. So when you are thinking about your forms and your subjects, you can make the ones that are closer to us warmer or closer to orange, and the ones that are farther away cooler, closer to blue. We can also use this to enhance singular forms. So let's take our normal red. I need to sharpen mine. Sharpen yours if you need to. I'm going to take my 924 And let's do just a little sphere. It doesn't have to be too big. But you still have to shade it with parts of the form, parts of a shadow. Okay, core shadow. Think about directional line and the contours of the form. Sure, your parts of a shadow should be in a circle. Huh? 924.
Alright, I have it already in my hand, so.
Yeah. Deflected highlight. And go ahead and just shade with just pressure. And this one pencil for now. And then we can take our cool red, so this is my 995, and I can add that to the farthest away parts, so like the very outside edge of that sphere, to tone the temperature of it down. I have an unfortunate scar in my paper at a bad place in my sphere, but it's okay. And then I can use that warmer red to the parts of the sphere that are closer to us, closer to the front and the highlight. And just subtly changing, it's still a red sphere, still, you know, gumball. But adding just a slight color variation with temperature in mind can really enhance that 3D effect, that push-pull effect. So I use my warm red to advance and my cool red to recede. You guys know what those words mean, right? Like advance, recede. Recede means to pull back or to fall away from. I'm not trying to be condescending or anything. I just want to make sure you know. Color in general, and color temperature are relevant to the colors around them. Okay, so while a cool color might look cool surrounded by all these warm colors, it might look warm when it's surrounded by cool colors. So in my little example up here, my middle red, my main 924 kind of basic red, is a warm red if I compare it to the cool red. But it's a cool red when I compare it to my warm red. So color temperature is relevant, which means it's kind of hard to get the feel of, okay? Because it's really, that's what it is. It's kind of like a feeling of warmth and coolness and comparisons between color. It is kind of hard to say if one single color is warm or cool. But it's easy to say that this one leans more towards orange and this one leans more towards blue when I have two colors next to each other.